I'm James Gepner with the Retrofit New York program. This is a Designing for Scale presentation, and I'll take a sort of broad overview of the market, followed up by Anita and Tony getting more and more granular as we go on. So first, this topic is about designing a product and a delivery process that can be applied at scale to address all the problems that we know well, climate being chiefly among them. So let's start with the end. What will things look like in say 5 years? This is a really important question to ask. The answer will tell us what we need to do today. It'll tell us how we need to plan, what we need to do to anticipate the future. It's also an exercise that reduces risk that we won't end up standing on the sidelines watching the future pass us by. So once we have the answer to this question, we can start to take specific steps towards that future. And make sure that our sort of each action is coordinated with what our goals are. We can also start to see if our business model and our approach is actually appropriate to where we need to be. So the first place to begin is with the product. Again, starting with a product, not a service. Right now, the industry operates with a service model where you take a bunch of resources to sites and then apply them. What we're proposing here is that we move to more of a productized solution. The benefits of this are numerous. First of all, we define what the product is. It's a panel, it's a mechanical system, it's a monitoring system. It has a certain modeled site EUI, a certain air circulation rate. And the advantage of this is the building owner knows exactly what they're buying and the lender knows what they're lending against. There doesn't need to be an extensive due diligence process each time. So for the building owner, again, it's about known prices and known outcomes. That's something you can't get with a service approach to doing a building upgrade or retrofit. The other thing about a product is it's repeatable and the scope is really defined thoroughly in advance and it's easier to finance. There are a couple other things listed here, including designing a product to a set of predefined typologies. So there's a market characterization study that you're going to hear more about later on in this presentation that lists the prevalent building typologies in New York State, breaks them down into 8 different typologies, and designing a product to each individual typology is a way to start a productized market. So how do we deliver such a product? Next slide, please. So again, let's start from the end and work backwards. What do we need that can scale a product, a retrofit product like this? We need a zero-energy retrofit company, one that has, is able to deliver a turnkey product, deliver a warranty, and spend capital to design that product, and be able to warranty it, and even potentially deliver a service contract to it. The advantages of this type of model are significant cost compression, which is, again, necessary for scale. And also, again, a company that's able to make replicable outcomes again and again across buildings of the same typology. Another advantage is this type of company can attract investment capital so that there's actually an ability to design a product, to purchase the necessary technology, and so forth. So this is really a key vehicle to having a scalable industry. So why do we think things are going this way? Well, and how do we know this is even sort of a viable approach? Well, when we look at what's going to happen in the next 5 years, we can just look at right now the layer upon layer of technology that are sort of coming into play, from installation with the technologies like Trimble's Site Vision, or financing with apps like Fundrise, or AI-assisted design from companies like MetaBuild, or tenant income models like Spacious. So from customer acquisition to financing, there's remote customer acquisition tools that can start to filter customers with the right building type, financing technologies that do, automatic valuations to reduce underwriting time, building capture technologies, as you probably all know, that make it easier to make design decisions, AI assist, as I mentioned, fabrication and installation software. So there's just so many technologies out, and each of them are finding their way into various aspects of the delivery process. These all promise to help make scale possible and also just drive to scale, make it not practical to do otherwise. So scale really is like when we talk about scale, scale is about access. A net zero energy building is, an amazing technological achievement, but one building doesn't solve our problems. So we really need to see how to vastly increase the degree to which we can implement it. And it's only with scaled implementation that we can start to address savings rates. Right now, studies have shown that something like 40% of people in the country can't afford a $400 emergency expense. Asthma and diabetes are on the rise. Sleep and focus are an issue. And of course, emissions. So the only thing really that makes us able to put a dent in these issues is scale. Scale is also a system. It's a system that draws a lot of resources to solve a problem, whether it's financial resources in terms of new financial mechanisms, new funding, bringing capital into this market, or resources to developing new technologies, or simply just human capital. Once you have a system in place, a lot of people can participate and start to bring their knowledge to bear. So scale is really imperative in terms of when we think about the size of the problem, to bring the necessary capabilities and financial resources to bear. It's also important to think about implementation. So let's just take a minute to think about what scale is and what scale is not. It's not waiting for a project. It's designing a product before there's a customer. And when I say product, I mean a whole building retrofit product. It's about a building with known outcomes and known prices. It's not about uncertainty about the ability to finance or waiting a long time for financing to come into play. It's about accumulation of knowledge, not doing a hospital and then doing a library without aggregating that knowledge and learning, within the team, but instead really applying that accumulated knowledge in each iteration. So when we think about, what's going to happen in the future, obviously it's, we can't predict the future, but we can come up, and it's wise to think about what are the most likely scenarios. Every time we make a decision, we're making a prediction of the future. A decision is a prediction. So when you order, a piece of cake instead of a piece of pie, you're basically making a prediction that piece of cake is going to taste better than the pie or make you happier. So we need to make predictions about what's going to be most effective, what's going to increase our odds of success, make us happier. When we look at, we start to craft scenarios and collect the research to inform our view of what the future will be and what those most likely scenarios will be, we can look in the R&D pipelines, look at the business models, look at unmet needs of building owners and the rapid changes in adjacent markets. All these things point to pretty significant drivers of change. Since I've personally looked at a bunch of R&D pipelines, I can tell you there's some amazing technologies coming out that, individually can make pretty substantial changes in this market. But when you put them all together, it has potentially a pretty profound impact. The same goes for business models. And so we're seeing a lot of them, like, Onion Flat's developer designer model, and the unmet needs of building owners, like the increase of insurance costs or flood risk, or carbon penalties. So these all come into play and are this type of things that really move markets and point to scale as a necessary thing to adopt and think about as we make daily decisions. So where do we begin? I've just done a high overview. I've made things maybe sound simpler than you may think they are. Well, we start by just working through a lot of these complicated challenges. We take specific actions, right? We start to isolate some of the variables, and we start to take steps like reading that market characterization study that Nina produced earlier this year, or late last year. We seek out different type of business models. Pick one prevalent typology and focus exclusively on it. Basically, take some action. Good intentions don't count, really. It's about the actions that we take. And again, the most important thing may be to just choose one of the complicated challenges and focus exclusively on that. So if we start from the end, we really see what our challenge is. There are about 10,400 days until January 1st, 2050, when we need to reach net zero energy. That is, if we do the math, about 610 retrofits required per hour in this country alone. So only scale is going to be able to match the size and the scope of that problem. So really, I don't see there being another viable way. So we might as well focus some of our energies to this, because that's really what we need to get there. So I think as a useful exercise, to start to develop that path, just think or imagine it's the afternoon of January 1st, 2050, and our goals, we've made it to net zero energy. We've succeeded. So what key steps did you take personally that were necessary to get you there? I mean, get out a piece of paper and list these reasons. This is really what is going to drive us there, is the collective action, but each person choosing a couple of things that is going to get us to that endpoint. And once you have those reasons, put them into your calendar. Because again, good intentions don't count. And unless you put them in your calendar, it's unlikely to happen. So picking some things that are within our control and start to work towards a scalable delivery is really key to this, making this market happen. And with that, I'll hand it over to Nina.
Thank you, James. So I understand there's a broad audience. So as I present, I'm going to try to limit the amount of technical language and jargon that I use. I'm Nina Sharifi. I teach in the School of Architecture at Syracuse University, and I have a lab over at the Syracuse Center of Excellence. The project that I'm going to speak with you about today is the SU Retrofit Living Lab. This is designed as a demonstration project to develop, integrate, and evaluate net zero retrofit on a dormitory building on our South Campus area. The goal is to really build out the knowledge around what it means to have a replicable model for retrofitting similar buildings. On our campus alone, we have 160, and in New York State, there are hundreds of thousands that feature important similarities as we're considering retrofit approaches. So we're at the beginning of optimizing for our criteria, our design criteria in our process. It's a 3-year project, so I'll talk about those criteria, some of the key considerations of scaling up retrofit using this context of a university campus. So it's a large landowner. They can undertake really large capital improvements kind of en masse. So it's a little bit distinct in that sense. Ultimately, we plan to scale up over the next 5 years to the development of, the 20-odd identical buildings or near identical buildings that we have at this Winding Ridge complex, and then ultimately kind of build out a true community scale model that includes site water management, storage, filtration, and energy sharing and potentially storage. So let's talk about the big whys for us. So the kind of global issues and how they translate to us at the university level and how they translate to the multifamily sector. So we've got decaying energy infrastructure. We're dependent on a grid that is set to become less and less reliable. We have an issue with reliability in energy and power delivery systems. This is coupled with increased demand from our growing populations, and we've got climate change that is causing more strain on the system. And then there's this kind of always on expectation as we increasingly live our lives, digitally and connected to power. So we're electrifying our campus at SU and our dormitories, and we're transitioning away, in line with the New York State decarbonization goals, not only from fossil fuels, but also from the kind of model of power delivery that relies on this decaying infrastructure. So how do we utilize the university to propose and test a new model for energy? We've got the system that was published by Lawrence Berkeley National Lab in 2015, which is the Driver's Needs Action System DNAS model. And it kind of shows the way that our behavior and our interaction with buildings and the way that systems can be designed to respond to that can help us to realize tremendous energy savings. And I think this applies to retrofit as well. And realize other kinds of efficiencies too. So for us, this kind of approach helps us to assess some of our assumptions, like how much air conditioner do we need? Can we achieve with daylighting what we had listed as electrical lighting originally, and so forth. So then there on the right, the example that I'm showing is the Dutch SMART Integrated Decentralized Energy System, or the SIDE system. And this is about kind of intelligent management to integrate these different components and balance supply and demand. So for campuses, as well as for multifamily housing complexes, these kinds of district scale demand side management and sharing start to be very interesting as a model. So Syracuse has a steam plant that serves part of the university. I know out in Utah, they've got a really huge underground kind of thermal water storage, and then Other institutions like the University of Texas at Austin is actually on its own microgrid. So it's an interesting model, I think, for universities and other large landowners with multiple buildings and properties to start to think about how we can become independent from this decaying infrastructure and have um, more resilience in the way that we deliver power. And it can happen at a range of scales. So structural issues can add to project costs as well. And of course, they need to be assessed with all retrofit projects, especially if we're considering EIFs or other envelope-based solutions that have to hang, right? And it depends on that structure to be sufficient. And so having to add a lot of structure in the end can really impact our upfront costs significantly and make it harder to achieve that financial feasibility, which is part of our project. And so we're kind of trying to understand capital improvement scheduling and the way that upgrades to existing buildings are handled and prioritized. And it's a bit complicated because we're competing with new construction and these really attractive ideas for new facilities that are coming through, like this rock climbing wall that you see on the right. And it seems that if it were just the management of the housing alone, that it would somehow be more straightforward. But this is one of the idiosyncrasies of the kind of institutional context. So you can see the kind of site plan here. And through this, I want to quickly kind of discuss the environmental factors. So we're looking at a number of flat roofs over precast concrete structures with good solar exposure. However, it wasn't really a priority with many of these buildings to design for kind of optimal ventilation. You can see a little bit of a kind of preliminary conceptual wind analysis that our students in our lab conducted. So we're exploring the feasibility on building integrated wind turbines. But these little bar buildings essentially have their units the units are stacked up. They're about 12 feet wide. They're these little shoebox units, the 2 stories each. And in these bar buildings that are being enclosed by this red rectangle here, each of those has 8 units in it. And so when we cut crossways through this block and look in, what we're seeing is really not a good condition for natural ventilation and fresh air to get through. And this analysis was another kind of drawing from our lab. But one of these openings on the ground floor, this one is actually the front door. So we can assume that there is no ventilation coming through there because we wouldn't have that open during operation of the building. And you can see there's a lot of dependency on kind of single side. There are no active ventilation systems in this building. And so, this is one of our priorities to think about for our context and for a lot of these buildings that didn't have air conditioning or any kind of forced ventilation installed, is this lack of fresh air and how to approach this. Is it ERVs? What is it? And so we have access to good fresh air, and it's kind of hard to get it in there. And of course, in a retrofit, we can't reconfigure the interior, right, and still call it replicable because that also gets to be quite expensive. And then our analysis starts to make sense. The drawing analysis starts to make sense when we see why all of our sensors that we've been taking data for about the last 4 months now are showing that we have really high CO2 levels. We have high total VOC levels, up to 4 times higher than the acceptable levels. So this is really problematic. And then this kind of ties us in terms of our considerations to this idea of the triple bottom line, which we might remember from the 90s when we started to have these conversations about sustainability. It was the kind of people, profit, planet. But for us, the people aspect is not merely social. It's really extending into the human health and wellness aspect of what we're calling that kind of total value proposition. And the next step is really to posit that we can have better design with better quality materials, improved IAQ, indoor air quality, and we can make it kind of financially feasible, let's say. So to expand on that, we're looking also at life cycle assessment as a method of evaluation. This being it's a retrofit, but it's coupled with kind of research and student engagement and public outreach and public education. So we're charged with looking at the bigger picture with this project. If we're thinking about this again as a demonstration in a sense for potentially many thousands of buildings, we have to kind of be conscious of what materials and systems we're using. Where do they come from? What do they do operationally while we use them? And what happens to them kind of after the useful life of the building? And so we want to showcase, to the degree possible, newly kind of commercialized products and materials. And then finally, we want to improve our projections and models with post-occupancy evaluation for a full year. So this is from our market characterization study that my colleague Gabrielle Brainard and I conducted last year for NYSERDA. The building types were categorized by vintage groups, construction technologies and practices, materials, as well as height. And this was really, it was a full New York State market characterization. So it wasn't national, it was just across the state. So within those typologies, this was kind of type 5, and the time frame was 1940 to 1978. So this was right before insulation really started to be mandated and to predominate in the kind of multifamily buildings stock that we see in New York State. And it was a time period in which there was a great deal of innovation and variation. But from a thermal performance and kind of construction and materials and techniques viewpoint, they share some similarities. So as a percentage of the total market, this is not trivial. So this type is categorized in our green box, which is our kind of post-war grouping. It's important to note that, again, buildings that were constructed prior to 1980 really were without any significant insulation. So the applicability is quite wide. It goes to the green box, but also everything above that green box. So we're going to, and there are similarities that certain approaches can share. So depending on how we define approach. So there could be a family of approaches potentially that could extend to those pre-war buildings as well. So then you go from about 20% of the market in the green box to over 60% when you include that pre-war segment. So moving on to our project context, our project aims to align with New York State decarbonization goals, electrification using materials to the extent possible that are non-fossil fuel derived. We've got a cold climate in Syracuse, New York, and climate is a kind of a key factor, as well as humidity, right? Temperature and humidity are aspects of climate that are really key to the development of, especially exterior envelope solutions. However, there's a lot of cold. There are a lot of cold or very cold climates in the United States, so we're hoping that there are at least, threads of what we develop that can be used elsewhere. Other activities in terms of analysis and considerations, we're analyzing the feasibility of solar and looking again at our climate, which is again predominantly space heating here in Syracuse. And in addition to that, we're trying to build out kind of a database that maps the existing kind of projects, ongoing projects, and component manufacturers as a landscape as that kind of rapidly evolves. So this is obviously crucial to scaling the idea of available materials and available systems, particularly those which are local to the United States. Because if we're looking at life cycle, we're not necessarily going to be, we want to encourage Northeastern and United States manufacturing. So, eventually we're thinking that this might become a kind of market research database that we collaborate with government and real estate entities to develop down the line. At our building scale, we've got a lot of exfiltration. We've got a lot of, really thermal bridging, really direct thermal bridging, these kinds of fins that are coming out. Those go all the way through the structure, and these slabs actually poke out through the side. That is what you're seeing. And then on the roof as well, we've got some pooling in some of these conditions. The thermal bridging and infiltration and exfiltration and roof issues, those are things that we kind of saw very commonly across this whole typology in multifamily as well. So these seem to be pretty predominant issues when we're considering retrofit. And then, every building has its own idiosyncrasies. Ours is going to require some abatement. There's some asbestos joint compound, PCBs in the windows, et cetera. So we've got to strategize approaches. I don't think this is limited to just our campus. I would venture so far as to say this is another issue that is happening elsewhere as well. And so this is a clear challenge for us, especially if we're considering things like retrofit in place. Also, if you're considering prefabricated approaches, just having a scan, a 3D scan of the building, for us, this took about 20 minutes for a 6,000 square foot building. And what it does is allows us to have much more accurate as-built in terms of the model. So that's really essential for prefabricated solutions. And then finally, we chose our test building because it's located adjacent to an identical building with the same orientation. So the idea is that we collect data, we construct our retrofit, we keep taking data, and we do a year post-occupancy evaluation, and we keep taking data. So it's quite an opportunity for us. Very rarely in architecture do we get the opportunity for a control in our experiment. And then we're kind of considering, what are some of the possible criteria in design that inform the way that we make decisions regarding specification of systems. So this is all contributing to some of the background research for us. And then the way we're defining performance of our materials and systems, we're looking to Passive House for guidance on our kind of path to net zero retrofit. So the building physics principles don't change, right? Thermal insulation, air tightness, minimizing our thermal bridging. So we're going to have to find some creative ways around that. But we want to, gain a better understanding of which of the measures are doing which of the work. We can say tentatively that the envelope is doing quite a lot of the work, but then, it comes down to the systems as well. So we're using energy modeling and kind of optimizing for across cost, across, comfort, visual, thermal comfort, et cetera. And we can kind of map that to the budget over time and determine what we really need. And then finally, the question is, what is replicable and what aspects of design, production of components, construction can be applied to other buildings within this type? Being part of one type based on kind of vintage construction and height gives us an idea of thermal performance and what to expect from the wall, the construction of these walls based on the standards at the time. But it doesn't necessarily translate into a kind of mass producible material size or a panel size or an assembly based approach. So I think it's important that we, at least for our context, really define what that means. And then, down to the detail level, we have a lot of options that exist with these kind of baked in trade-offs that tie into everything from, the appearance, the aesthetics, the cost, the culture, and so forth. So we're trying to kind of build up that detail library. We can say conservatively, since we're very early in the process, like I said, of kind of testing. So, we can state that computational methods, there are some kind of remnants of mass customization, mass production, development, design, and production methods, prefabrication, correct installation, right? In terms of education and training is so crucial and often is a source for a lot of energy loss and energy inefficiency. So well-designed connections. And then again, I want to emphasize a post-occupancy evaluation to get better data and better models. We know prefabrication can reduce material waste by 30%. That's pretty significant given the 300 million tons that the US produces each year, 40 to 50% of which is C&D, construction and demo waste. So that's really quite a lot. So this will be one of our topics of study for this project, to look at the estimated waste saved on the project and share that information with solution providers. So enabling technologies in mass customization, like BIM, just being able to model every bit of the piece, every piece of the part in the system of the model, right, as well as to, again, measure the existing condition and produce something that fits well in the space, can absolutely scale as an approach. So as in the shop, the project for the Barclays Center, I think there were 11,500 unique panels on that facade, or the Kieran Timberlake bathrooms at Yale University that you see on the lower right here. So there was not one unit, but sort of a family of units that could fit into different spaces. And then finally, we want to look at this potential for mass customization that kind of renders solutions that are criticized as being kind of devoid of culture, and we can kind of begin to depart from that. By understanding the market, understanding the idiosyncrasies of the building stock very well, and considering kind of emerging technologies and emerging approaches as well that can satisfy groups like preservation, right? So potentially using 3D printing, using hybrid low carbon materials, kind of lightweight replacements for elaborate stones in Brooklyn, for example. So it's a really rapidly evolving ecosystem of technology, products, and ways of thinking about design and production. So that can kind of, in addition to that, I think the integration of data into our methodologies on a scale that's unprecedented can really contribute to improved retrofit approaches. Thank you. So now we'll pass it on to Tony from Cycle.
Well, okay, so thanks very much, Nina. I just want to begin by saying that due to some unforeseen circumstances at the time of recording, I had to make this presentation alone. Caitlin is going to be available during the Q&A, and hopefully you caught her talk on the St. Mark's Passive House project over at the Passive House Accelerator on Tuesday evening. So for this part of the presentation, our focus is going to be on what makes a deep energy retrofit solution. It's the forward-looking part of it, I guess. We're going to be looking at the solutions, not so much at the challenges, and you'll hopefully see some of that thinking in this part of the presentation. We're going to look at what characterizes a solution, what a solution integration looks like, and finally we'll look at some details. So this is my take on the challenge that has been so well laid out by James and Nina beforehand. Look at all of these buildings, and not a one of them really, well, except for the, I guess Paul Castrucci's done one, and Chris Benedict's doing one, and I mean, really, multifamily buildings, there really aren't a lot of deep energy retrofits out there. Before we get into the details, I think it's important to understand what we're talking about. Please indulge me with a few concepts. Simplicity. This is a salad. It grows in the garden. You pick it, you put it in a bowl, you eat it. That's it. This is a burger. It's a bit more complex. It's not simply going to the garden or the lumber yard. But there's an integration here of a lot of different elements, and you can see that some of these elements are raw, like the lettuce. The burger itself is a mix of vegetables and sauce, a bun from a bakery. It's all integrated, but it's still a single burger. And one thing that's important to note is some things are not a part of the integration. Another characteristic of a deep energy retrofit is that it is an equitable solution to living in urban spaces. And you have to imagine that you are looking at a zoomed in close-up of that overall view that I opened the show with. Every one of those buildings has its own culture, has its own residents. It's part of a streetscape. There are, multiple generations that live there. And there are things about retrofits inherently that are equitable, but also, we have to, when we design our solution, we have to bear this in mind. And, there's a list of the items right there. It's fairly self-evident. When you do a retrofit, you're making an improvement and you're not displacing people. So their equity in a neighborhood is maintained. And that's an important concept for this discussion of solutions. So let's move on now to integration. As designers, we're used to seeing every opportunity as a blue sky. But a retrofit solution forces us to consider that we are looking not at a blue sky at all, but maybe the outline of something that's already pretty well defined. Through her work that she just presented, Nina is working on defining exactly what you have to address with the retrofit and what the issues are, and we see them across all of the various typologies. But the closer we get to a solution, the more some of these integrations start to become clear. And one thing that's important, I guess maybe the first principle of integration, is that for a solution, there's really only one integration. There's only one solution per typology. Now, I'm not saying that everybody who's providing a solution for that typology has to have the same solution. I mean, that's what the market is there for. But there's only one solution that you as a provider, as a designer, can provide. If we're going to achieve the kind of scale that James is talking about at the outset. We're no longer blue sky designers. We are implementing a solution which has already been kind of figured out. This is what I mean by that. First of all, there's this element of predictability, as James mentioned. Whoever is purchasing and financing the solution, they have to know what they're getting, just because, the cost of a once in a generation retrofit repair is going to be expensive no matter what. It's always going to be a major capital investment. There's some other factors here: repetition, standardization, which, to stand to reason would be a part of any kind of a solution. Finally, I'd like to address the idea of specialization, and that is that there are elements to a solution that are really of that solution. It's the right piece in the right place. And just to give you an idea of what I mean by that, let's take a look at this example. Many of us, I would dare say all of us, have worked with a device similar to the one shown here. As you can see, it's an agglomeration of many different components, and they may not be made by the same manufacturer, but they're all put together by one original equipment manufacturer. If it's whether it's Apple or Dell or whoever, they're buying chipsets from Intel or AMD, or they're buying graphics cards from NVIDIA. They're buying drives from Seagate. I mean, there's a whole ecosystem of manufacturers who are providing specialty parts for laptop computers. But, you might look to the laptop computer for, well, you might buy it because it's got an NVIDIA graphics card of the right type. But really, you're not buying the graphics card separately. You're buying the computer. And, likewise, we would see this as a solution when it comes to doing deep energy retrofits. Here's another fairly well-known component that is a solution for driving on roads. It might not be the only solution in the future, but it's certainly one. And I guess just we can take comfort, as architects and designers, in the fact that when you go to buy a car, you have a very, very wide variety of choices, so while I said there can only be one solution, I mean, I'll amend that and say there can be many models of that solution. So you can have a little bit of variation in performance, appearance, cost, et cetera, et cetera. So now let's turn our attention to some of the details. I will share some details that we've been thinking about for some of the work that we have been doing. We are looking at doing panelized exterior cladding solutions for buildings, and in this case, the idea is really to integrate as much as possible into this exterior cladding system. We want to integrate a window and a heat pump, energy recovery ventilator, any sort of supporting conduit and piping. All of this can be integrated more or less into this exterior panelized cladding system in some way. There are other ways of doing it, but we don't think they're as promising as a solution. Just let's take a little closer look here at the detail here. A solution really is going to rely as much as possible on what's given by the building. So, we look at, taking down the sill maybe by a little bit, or using the existing window opening for the integration of our mechanical equipment. There are some other considerations, obviously. We have to make some kind of an anchor attachment to the building. We have to remove the existing window, of course, and provide some kind of interior trim solution around that. But by and large, we're trying to, eliminate as much work in the balance of the building as we possibly can, because we want to keep the building occupied. So that's going to require a little bit of specialization to reach that aspirational goal of just integrating everything into the panel. First thing, packaged heat pump units. These units are on the market in Europe, and they're coming to market here. They've been tested and certified, you can see very compact physical form for the unit. It has an exhaust out the back, and we are proposing to integrate that exhaust into a plenum that goes out through a louver, which is integrated into the into the design of the window. Basically, we could have a separate louver in the panel, but for our purposes, we thought this would be a little bit advantageous in the detailing, since window manufacturers generally already have details for incorporating louvers and vents into their windows. But still, a lot to work out. But it's a discrete engineering challenge, that can be met. It's not a conceptual challenge. Likewise, attaching to the building. Usually a panelized system is going to, have, most of the insulation on the outside, and there won't be a lot of thermal bridge. But, exterior panels are structural, and they have to be supported from the building structure. So there is actually, at every point of attachment, some kind of a thermal bridge. So we look to manufacturers of masonry accessories, like Faro or Homan and Barnard, Halfin, who make these kinds of attachments. They say they can make anything, and indeed they can. What we're looking at here is a thermally broken attachment for a steel shelf angle for a masonry veneer. That's not exactly the application that we would have for supporting a panel from the building, but it's pretty close. We would look to that industry to help us develop, the kinds of attachments that we need to get the performance that we desire in this case. So, energy recovery, again, we're looking at solutions that go through the facade, rather than having, complex systems of ductwork on the exterior of buildings, or worse, on the interior buildings. We have there's the Lunos type, where you have a paired ERVs that just go simply right through the wall. And there are some European, single module solutions as well. There are a number of pieces to a deep energy retrofit that are standalone. You can see them listed here: solar, battery, et cetera. They just stand alone. Perhaps the biggest and most impactful of these is changing out the a building domestic hot water system for electric heat pumps. It's an example of that there. So what's not in it? What's not in the burger? Where are the grommets? What's not integrated? Centralized systems. Again, rooftop mounted, VRF type systems have refrigerant piping that's got to be somehow integrated and run to the interior of every unit, uses refrigerants that are ozone depleting and, will probably have to be abandoned in place. You just can't change out the refrigerant. We prefer package systems, and I think the diagram shows it. Kids, am I doing this right? I'd like to close by offering a few words about the aesthetics of these kinds of panelized systems. We are generally talking about making flat panels to enclose buildings. That's the simplest, the cheapest, the easiest thing to do. But just because it's flat doesn't mean it has to be dull or devoid of culture. You can use fabric as an example. And there are all kinds of patterns, pixelations, color palettes. All of these elements can make up a part of a solution, and there still is plenty to be challenged by, with each individual building. It's just there are places where you can do it, and places where it just doesn't make so much sense. So, finally, I have one last thought before I close. Obviously, regulations are going to bear a lot on any potential solution. Often we have conditions where if you want to enclose a building, there is an encroachment over a street line or a lot line or into required open space or yards. Fortunately, the New York City, at least in New York City, the Department of Buildings has been looking into this for the next round of code revisions. And June 14th, it's Monday, there's going to be a public hearing. I encourage anyone who's interested to tune in or to actually try and participate. You have to get your comments in quick, but there's still a way to participate. Basically, the building code is going to be revised to allow encroachment past the street line. This is huge. It means a lot of buildings that might not be able to be retrofit will be able to be retrofit. However, there are some catches there. They're going to allow 8 inches encroachment, 10 in some circumstances, and 12 in some circumstances when you get special permission. But the reason they'll give you that permission or allow the encroachment is to comply with energy code. That doesn't make sense. To comply with today's energy code is not the same as doing a future-proof, once-in-a-generation deep energy retrofit. We would like the standard for acceptance not to be simply complying with the energy code, but rather to complete a net zero energy retrofit or a future-proof building, whatever you'd like to call it. So to sum up, we started by thinking in terms of broad concepts, some thoughts about equity and integration were shared. Some detail concepts were shared, and we've closed now by getting down right to the nitty gritty. What is the Department of Buildings going to allow us to do? All of this is a part of a solution, and hopefully we've shared enough information to get you thinking about your own approach to how we can solve this immense challenge. And with that, I think I will close my presentation. And I guess, James, Nina, we can start taking your questions.
My name is Gabrielle Brainerd. I'm going to be moderating the live Q&A. Hopefully everyone can see us in our hybrid configuration. This is a really fascinating topic, and it's just so important for New York City, as I think came out in some of the presentations. So I'm going to sort of throw out one question to all the presenters to start with, and then we'll also pick up some of the questions from the chat. Reminder that you can upvote questions that you'd like us to answer live, and you can also continue to add chat questions as we're talking. So I think every presentation kind of mentioned these productized solutions. You know, James talked about creating retrofits that are a product, not a service. Tony presented some images of cars and computers. Nina talked about, you know, what is replicable. Maybe it's the software, maybe it's the training. So I wanted to throw this out to everybody. Architects have been talking about productized solutions for a really long time. I mean, Le Corbusier was talking about the relationship between airplanes and ships, and why can't buildings be more like that, you know, 100 years ago. But this has been a persistent challenge for the industry. So I would just ask, how are we going to make this work? And are there any precedents that you see out there where you're seeing AEC products or services in the AEC industry that are actually successfully kind of delivering these outcome-based rather than service-based models?
Well, I can begin, I think, by just noting that if you look at building in the United States, as a whole, there's an enormous percentage of building that is, not done as, as a design service. There is already a mass building industry here. What there is not is a mass retrofit industry. In the mass building industry, you can go to any lumber yard and get the same 2x4s and plywood and whatever. It's kind of universal. That has not been developed as of yet for retrofits. So that's the first thing. The second thing is that just in keeping with the with the challenge, either we're going to be able to do this or we're going to fail. I mean, that's those are the two options. I mean, we are aware of manufacturers who are bending their minds to think about how to do this. Both in the sort of the panel construction sector and the mechanical equipment sector. And we're seeing people beginning to develop the specialized kinds of products that can be used for this. So, I don't know. I mean, maybe we'll get enough traction to really start doing this. I mean, we have some pilot projects already started. The people that we've met in our work doing this kind of work have been very enthusiastic, have been willing to share a lot of information. It is I don't know. It's in some ways it's a warming challenge to be faced communally with many different players across an integrated team to come up with a solution.
Does anyone else want to respond to
I
that?
can take a stab to add to that, Gabby. Can you hear me?
Yeah. Mm-hmm.
Okay, great. I would just add, I agree with what Tony is saying. I would just add to that there are multiple players in the ecosystem. It has to be bottom up and top down. The AEC industry is known to be not excellent at PR and public outreach and public education. And I think, you know, as you were saying, Gabby Le Corbusier and then Bucky Fuller, of course, or the Demaxian, and then prefabrication, you know, in the mid-century became associated with trailer homes and poor quality construction, and that public perception lingers, right? There's an inertia there, being associated with poor quality construction, with prefabrication and so forth. So, I mean, I think one of the things that James and I were discussing when we first jumped on to record this thing was, wow, you know, the people from our respective industries, from, you know, within academia, from within architecture, from within finance and real estate, don't talk enough, right? There's not enough kind of exchange of ideas and collaboration and working together. So I think that's key as well, is creating the mechanisms through which we can collaborate and formulate strategies and solutions.
Mm-hmm. James, do you have any, you know, since you were part of putting together the Retrofit NY model, do you have any like precedents that you're looking towards in the AEC industry?
I would just say, you know, some questions are, the way they're framed, they seem daunting. And when you say like, how can a scaled approach be tackled when it's, you know, 100-year-old problem? Well, which variable? Like, which variable is it sort of moisture problems with sizing on the panels? Because I've heard some great proposals about that. Is it the longevity of the gaskets between panels? Because I've seen proposals about that. Is it the digital process? Because already in Europe, they're very advanced there, and there are new technologies here all the time. I would say the ESCO model and automatic valuation algorithms are already like taking variabilities out of finance and basically monetizing energy savings. So really, what's the variable that is going to hold us up? And I'm not saying there aren't some that are going to be really daunting, but when we isolate the variables, we find out, okay, there are a couple of ways to go about this.
Mm-hmm. Going to some of the questions, a couple people, it seems like a couple people were really interested in this question of encroachment issues and the code. I guess that's kind of a persistent stumbling block for different municipalities. I mean, Tony, what do you think? You kind of brought that up at the end of your presentation.
Yes.
The zoning. Do you want to speak to that a little bit more? Because it seems like some folks in the audience are.
Sure, I can speak to that. So the New York City zoning resolution was amended, I think, in 2008 or 2009 to permit encroachment of 8 inches of insulation, past, into required yards. And above the roof, above the maximum height. We had a conflict with the building code. Right now, the building code is being amended. And as I mentioned in the presentation, there's a hearing on Monday at which they will consider the new code. The new 2021 New York City building code will permit encroachment of up to 8 inches past the street line, the property line into the city street, 10 inches above 10 feet above grade, and then 12 inches if you, very, very nicely ask the commissioner for a break. But the problem is they're saying, well, it's only to meet the New York City Energy Code. That's, So, I mean, if you can meet the New York City Energy Code with 2 inches, then are they going to deny you 8 inches, which is what you need to get to net zero? So, this is something that we have to keep an eye on and remain engaged with lawmakers and policymakers as they address these issues.
Mm-hmm. I mean, I guess one would hope that the building building department in New York City is in sync with some of the policies that are being promoted by other departments in terms of retrofit and our overall emissions reduction. Let's see, looking at a couple of the other questions. There were a few about zoning. I wanted to bring up a question about building types. So one of the interesting things about the two case studies in this presentation is that these are both like potentially really scalable building types. Looking at NYCHA buildings, you've got one owner, many very similar buildings. They're all pretty large. Same thing with the university context potentially. But a couple people were asking about kind of other types of buildings, like maybe curtain wall construction or highly glazed buildings, or buildings that are taller than 5 to 6 stories. I mean, does anyone want to kind of speak to that? Are these replicable solutions really only going to work for certain building typologies? And if so, how do we handle the fact that, New York City is a vast and diverse landscape of buildings that are all really unique, and how do we tackle that challenge?
Well, curtain wall buildings are going to pose a real challenge to this. The solutions that I've seen that address curtain walls, unfortunately, are all interior to the into the curtain walls. So, much harder to preserve interior spaces in people's homes. So if you are unfortunate enough to live in a a curtain wall building with floor to ceiling windows, if you're going to retrofit that, it's most likely going to be the result of applying some kind of an interior panel. Structurally, to reclad a curtain wall building, as anyone who's tangled with this before would know, you basically just have to take off the existing skin altogether.
Yeah. So some buildings are much more challenging than others. So there were some questions about there's one question I really liked that was asking about, are these retrofits like the $299 laptop or the like $1,500 MacBook? And I think that kind of speaks also to the equity aspect of Tony's presentation. Another person asked whether passive house construction is more attracting kind of higher end architects and contractors, or more kind of like general builders. So, I mean, maybe we all know retrofits are really expensive, especially with when the envelope is involved. So maybe someone could talk a little bit about cost and what the kind of price point is of these systems and how that is being addressed.
So I can chime in there. I think cost is a little bit of a misnomer because there's tremendous value and there's tremendous extension of longevity of these buildings. So the fact that you're getting a much longer lasting building, if it's a multifamily rental, you're getting additional years of rents that you wouldn't be getting with a conventional upgrade. And so those additional years of rents are, I think, effectively paying for it. So I think really that part of it is, we want to drive down costs, we will drive down costs, but financing mechanisms are going to be one important solution here. And that, valuing the unique attributes of a zero energy building is going to be key to making them financeable. Mm-hmm. That said, the point at which these things really take off is not when, I want to say, cost gets below a certain point, but when the upfront capital investment by the building owner gets to be at parity with a conventional upgrade. So if there's a financial mechanism that pushes that off to, throughout the life of the building, or any number of mechanisms like ESCOs that can finance those savings, then that's going to reduce that upfront capital cost. So I think that's the place where we should be looking in. And in my view, the answer is yes. We're driving towards that mark rapidly.
I would just
Jane,
add,
oh, sorry, go ahead.
I would just add from a different perspective, working within research and kind of the components, innovation and fabrication area. These costs we expect to go down as well as the kind of ecosystem gets stimulated. And, I remember a couple of years ago, we were looking all over for manufacturers of retrofit components, and we were really hard pressed to find very many in the Northeast region in New York State and the surrounding area. And I think there has to be some parallel kind of development of these different players and entities in the ecosystem. So we've also got to bring down the cost of systems. And, I think just from kind of seeing a lot of that happening, I think, with sufficient R&D, we can be in parallel with, what also, James, I remember you and I had discussed earlier about, human health and wellness and, overall the burden on the healthcare system, for example, the burden on human, quality of life. It's about the occupant, right? And we're seeing that in more emerging standards and guides as well. So having these things move forwards, we'll have better materials, materials that have, better improved kind of carbon emission and footprint performance, improved life cycle performance in parallel, so we're developing solutions that we can keep using right into the future.
Mm-hmm. I want to pick up on one question that Tim just put in the chat, and it's primarily for James. So James, you were saying that, scaling is about designing a product before there's a customer. So how do we create customers for this product? And Tim in the chat just said, this discussion illustrates the dire need to advance building energy codes. So there's sort of like the carrot and stick idea. How do we actually convince or push people to actually do these very expensive and, complicated projects?
So whenever you're trying to get a person to do something new, I think the place to look is not at necessarily the attributes of this new product or this new behavior, but rather what is the threshold of intolerance for the status quo? What is driving building owners away from conventional buildings? Is it tenant non-payment rates because such a large portion of the population can't afford emergency expense? Is it rising insurance costs, which are really rising at staggering rates? Is it the difficulty of actually getting a conventional upgrade because the labor force is aging and less people want to get into the labor force for conventional upgrades? Is it potential carbon penalties or energy costs? So there are all sorts of existing reasons that are making the current business model for building owners untenable, and they're only going to gather steam. So when we look at that, things pushing in that direction, then going, okay, so how does this new solution solve those problems? And it does across the board. It's a complicated picture because it doesn't just solve one thing. Energy is a nice kind of big picture thing. And if it paid for everything, then great, we maybe wouldn't have this conference, right? But there is a picture emerging that shows, okay, when you go through the building owner's business and what pressures are on them, that this is a solution that addresses those currently unmet needs. And I think that's the way to look at it.
Mm-hmm.
James,
so
if I might just
go ahead.
I just wanted to add that, thank you. I just wanted to add that every building at some point in its life is going to need a major overhaul, and it's going to need to be retrofitted. And, at any given year, retrofit projects are happening because buildings have reached a point where they're no longer viable. So, this is going to be true of every building. Every building will have to be retrofit. And, we're looking now for customers, for our business, to people who, need that, whose buildings are, at the end.
Okay, last question, because we're almost out of time. We're kind of over time, but so this one's for Nina. So Sarah is asking in the chat, just lost it. Do we think there's enough exploration and activity on this topic underway in our design school?
Without being critical of any one particular institution, yes, I think students are woefully unprepared across the board, regardless of pedagogical approach in the field of retrofit and design. Although I will say, I'm seeing courses pop up in various institutions, especially those which have programs that include some components of building science as well. And so there's not so much of this wall between kind of architecture and building science worlds. Those who have, more of an interdisciplinary and, forward-thinking pedagogical approach, teaching and curriculum approach. We are seeing that start to emerge. It's something that, given our responsibility as institutions to prepare our students for not the world that we grew up in, right? The world that we must prepare them for the next 10 to 20 years. We're talking about retrofitting millions of buildings between now and 2050. That's it. We have to start integrating this, in my view. Obviously, this is just my individual view. But yes, I think it's desperately needed that there are materials that and obviously it's a rapidly evolving field. So, maybe it's not the traditional teaching model of having, a textbook, right, that gets updated every 5 years or so, but having a more fluid influx of updated knowledge. Yes, I think it does need to be integrated. Great question.
Thanks, everyone. I'm going to wrap it up. Thank you so much to our presenters. As I said, this is a fascinating topic, and I can see by the activity in the chat that the audience is really engaged as well.